Okay, today we're going to be studying about ratios and proportions, and this is the content standard and the mathematical practices we'll be using in this lesson. Previously, you've solved problems by writing and solving equations, and now we're going to write ratios and write and solve proportions. Do you remember that vocabulary from 7th grade? Okay, we have 6 new vocabulary words today: ratio, extended ratios, proportion, extremes, means, cross products. A ratio is a comparison of two quantities using division. The ratio of quantities A and B can be expressed as A to B, or it can look like a digital clock where it has A and then 2 dots and a B, or it can be written as a fraction, A over B, where B is not equal to 0. Ratios are usually expressed in simplest form. So let's look at this example. The number of students who participate in sports programs at Central High School is 520. The total number of students in the school is 1,850. Find the athlete to student ratio to the nearest tenth. So first of all, we're going to divide the number of athletes by the total number of students. So the athletes, notice it's 520 to every 1,850 students. So 520. Now, you could write this as an equivalent ratio. 52 over 185 is equivalent. So how do we find out this answer, 0.3 or 3/10? Well, we take 520 divided by 1,850, or 52 divided by 185. We round it to the nearest tenth. That's what we've been asked to do. Since this can be written as a fraction, as a ratio, the athlete to student ratio is 3/10. Okay, time for you to check your progress. So pause the video for a moment, read the problem, come back and check your answer. Did you get answer C? You should have set up your ratio 251 over 365. And that comes out to be 687 thousandths. If we round it to the nearest tenth, 7/10. Now, extended ratios can be used to compare 3 or more quantities. The expression A to B to C means that the ratio of the first two quantities is A to B, the ratio of the last two quantities is B to C, and the ratio of the first and the last is A to C. So we could say 5 to 12, 12 to 13, and 5 to 13. Okay, so let's look how we use extended ratios. If in triangle EFG the ratio of the measures of the angles is 5 to 12 to 13, find the measures of these angles. So just as the ratio 5 to 12, or written 5 to 12, is equivalent to 5x over 12x, or we could rewrite it 5x to 12x, the extended ratio 5, 12, 13 can be written as 5x, 12x, 13x. So we can write and solve an equation to find the value of x. So first of all, what shape are we talking about? A triangle. What do we know about the measures of the angles of a triangle? Why, they all equal 180 by the triangle sum theorem. So we can set this 5x plus 12x plus 13x equal to 180. Combine our like terms. 5 plus 12 plus 13 is 30x. Then we divide both sides by 30, so x is equal to 6. So the measures of the angles are 5 times 6, or 30, 12 times 6, or 72, and 13 times 6, or 78. You can check your work. Is 30 plus 72 plus 78, is it equal to 180? By golly, it is. So time for you to check your progress. So pause the video and work this problem just like we did the example before, and then come back and check your answer. Okay, when I set 3x plus 5x plus 7x equal to 180, I come up with x is equal to 12. So 3 times 12, 36. 5 times 12, 60. 7 times 12, 84. And do these all add up to be 180? Yes, they do. An equation stating that two ratios are equal is called a proportion. So A over B is equal to C over D. The number A and D are called the extremes of the proportion, and B and C are called the means of the proportion. And in this, of course, we cannot have a 0 in the denominator, so B cannot be equal to 0 and neither can D. So if A over B is equal to C over D, when the denominators are not 0, then AD is equal to BC. Let's put some numbers in there so you can see. So 4/10 is equal to 6/15. If they're equal, then 4 times 15 is equal to 10 times 6. So the product of the extremes AD and the product of the means BC are called cross products. Okay, so let's look at cross products. 6 times y, so we're crossing the equal sign, is equal to 9 times 18.2, which is 163.8. Then we divide both sides by 6. So in this instance, y is equal to 27.3. This one's a little bit more involved, but we still use the same process. 6 times 4x minus 5 is equal to 3 times negative 26 by the cross products property. So use the distributive property. 24x minus 30 is equal to negative 78. We're going to add 30 to both sides and then divide both sides by 24. So x is negative 2. All right, time for you to check your progress. So pause the video and come back and check your answer. Did you get 4.5? 42b is equal to 13.5 times 14, which is 189. So then I divide both sides by that 42 and I get 4.5. Let's try another one. 2 times 7n minus 8 is equal to 8 times 15.5. So you get 14n minus 2 is equal to 124. Add the 2 to both sides, divide by 14, we get n is equal to 9. Now proportions can also be used to make predictions, so we can use this in real-world problems. Monique randomly surveyed 30 students from her class and found that 18 had a dog or a cat for a pet. If there are 870 students in Monique's school, predict the total number of students with a dog or a cat. So out of the 30 surveyed, if 18 of them had a pet, we can set it up as 18 is to 30. So 18 of the 30 students had a pet. So how many of the 870 students had a pet? So these are the total numbers. This is a sample. So we're trying to find out what the total population would bring us. 30x is equal to 18 times 870. Divide both sides by 30. So based on Monique's survey, about 522 students at her school have a dog or a cat. So we can make a prediction about what the total would be. All right, time to check your progress. So pause for a moment. Remember to set up your proportion and then do the math. Did you get 324? I set it up. 20 over 50 is equal to x over 810. 50x is equal to 16,200. Divide both sides by 50. I got x is equal to 324 students. Now the proportion shown in example 4 is not the only correct proportion for that situation. There can be equivalent forms of a proportion and all have identical cross products. Notice we're always multiplying A times D and B times C. We're just putting them in different places, but always A times D is equal to B times C. So it doesn't matter as long as you've got this type of proportion set up, they're equivalent. Okay, time for you to start your assignment.